Had we known in the early 2000s what we know today, which is that your own stem cells can do the work, this whole field of collecting stem cells, tweaking, like this whole part would probably not have developed. You have stem cells, which is nothing. They're almost like blank, but their ability is to become any kind of these other cells. They are the repair system of the body. So they leave the bone marrow, they go wherever there's a need for repair, and they migrate in that tissue and then become cells of that tissue. But our health is really a balance between losing cells and replacing them. Your stem cells are working. If they were not working, you would not be alive today. If you have a new liver every 2-3 years, and you're still good today, that means your stem cells are there, they're doing the work.
You've created a product that I've actually been taking for about 5 weeks, a Stem Regen.
Stem Regen Release, today Stem Regen Sport, is the primary product. The power of just releasing your own stem cells. When that finally gets well documented, we publish all these studies and we really show what this can do, releasing your own stem cells. For the vast majority of the people, that will be the best thing to do.
Hi, everyone. This episode of the podcast is sponsored by Stem Regen. Hi, I'm Gabby Reece. I'm your host. I'm also a retired professional volleyball player, co-founder of XPT Fitness and Laird Superfoods. And on this podcast, what I really want to do is interview experts about the latest in health and fitness, not only so I can learn, but really so you can maximize performance in all areas of your crazy busy life. In today's podcast, I'm talking with Christian Drapeau. He's the founder of Stem Regen and a pioneer researcher in the field of stem cell research. As you'll hear in our conversation, there is a lot of potential for stem cells. I mean, this can really change our lives, from its potential impact on chronic diseases, leukemia, Alzheimer's. I mean, you name it, even your skin. Stem cell research may be one of the most important innovations in our lifetime, but really compared to things like AI, it's barely discussed, and when it is confusing. So I thought it was time to bring Christian onto the podcast to discuss his research and what his findings mean for the future of humanity. Well, humanity, our health, our longevity, how we're feeling. Anyway, let's get into it. Welcome to the Gabby Reece Show. Let's go. Christian, welcome to the show.
My pleasure.
You've been on a bit of a journey. Literally.
Since?
How many years? I know you're just flying in, but
right.
When I was doing my homework to get into this conversation today, the stamina you have to take on the conversation of stem cells, and even, I feel like creating a product around stem cells was kind of like the next move. It didn't feel like somebody who was studying, algae and other things had it in their mind that this is where they'd be.
Oh, absolutely. It was, what I like about the story is that it's really the story of the scientific method, if you want. You observe something, you don't know how it works, you have a hypothesis, you test it, and one thing leading to another, it led to stem cell research.
Would it be safe to say that you're a person who grew up more as an academic than somebody who was interested in health?
I studied plants since in my teens, so I was interested in it early. But my superpower is just to ask questions and try to answer them without being framed by the traditional knowledge, if you want. If I observe something and the theory says it should not be true, I'm going to drop the theory and stick with what I saw. So I think it's that thing that allowed me to basically end up where I was with stem cells.
I'm always curious when people, like scientists, who really the whole objective is to almost go in and prove yourself wrong. Yeah. Most of us are trying to prove ourselves right. And a lot of times scientists go with this mind of, well, let's see.
Yeah.
Are you actually able to do that in your day-to-day life? As a person?
I don't think I'm that scientist. Like for me, I look at you take 10 different elements that everybody sees them separate, and I see how they're connected. And I'm trying to push us to, so you need to visualize or have an idea of how they're connected, and then I go test for that. So if you try to disprove it, then you never achieve anything in the way that I approach it.
Right.
So for me, it was to take all these pieces together, and the only way to explain how it was working is that this thing about stem cells had to be real. But in my life, I'm very intuitive. I do everything in my life even in science, from how it feels. And then I prove it.
I like that. I think it's very hard. I think it's hard to do that. in this world. I think we're set up to have everything sure. And so when I was getting ready for this, I thought it was just a very interesting story that you sort of started in one spot and now you're really in a very different place. So let's talk about that. How do you go? What's the journey for you and having this realization about plants and the improvement of stem cells? And then just for third grade purposes, let's talk about what stem cells are.
Okay. I think the best way to explain what a stem cell is to explain first what is not a stem cell. Like everything in your body are somatic cells. They do one thing. They'll never transform. They'll never multiply. You take a cell of your muscle. If you go to the gym and you like tear a muscle, a cell of your skin won't look down and just say, gee, the muscle needs help, so let me go down and become a muscle. They remain what they are. At the other end of the spectrum, you have stem cells, which is nothing. They're almost like blank. But their ability is to become any kind of these other cells. And that's what they do. They are the repair system of the body. So they leave the bone marrow, they go wherever there's a need for repair, and they migrate in that tissue and then become cells of that tissue. So that's what they do. And historically, they were known to be precursors to blood cells. So really the big discovery that has led to what today is stem cell research is to discover that not only they can become blood cells, but it turns out they can become pretty much everything in the body.
When was this first discovered? How long has it been? I mean, listen, it's been topic of conversations, and you hear people going to Mexico and Costa Rica and Panama and all these places. But when was it realized that you had these cells in your body that would really go to the place of need? Who figured that out, and how did they figure that out?
I mean, in real life science, nobody really discovers something new. It's always build up on what somebody else has done, and you bring pieces together, and it's a new thing, but it's from pre-existing things. So we've known for a long time, let's say since the early 60s, that we have such a thing in the bone marrow that is a stem cell that will give rise to blood cells. So we've known that for a while. We've known that for a while, that you have such a thing as an embryonic stem cell because you've cloned, you remember the sheep dolly. So this has been there for a while. What really became the birth of what is today's stem cell research is when somebody was able to grow human embryonic stem cells. And so that really reopened the door to, gee, what can we do with these? Maybe we can regrow organs and heal people.
So you're saying that it's not like, oh, they had this one moment and here we have stem cells. It's sort of all this story coming together and then people realizing, oh, and we have this coming from the bone marrow.
We knew that stem cells in the bone marrow were precursors to blood cells. But the moment we started to really work with human embryonic stem cells, then we used the methods to grow human embryonic stem cells and applied that to bone marrow stem cells. And it did not work well. So in the very early days, so we're in 1999, 2000, stem cells from the bone marrow are not really as good. They're not really good stem cells. And then people started to work with adult stem cells from the bone marrow, growing them using methods that were but appropriate for these stem cells. And then suddenly the whole thing emerges that if you take an adult stem cells from the bone marrow and put it in the liver, well, it becomes a liver cell. You put it in the pancreas, it becomes a pancreatic cell. So slowly that information started to grow. And in 2001, as I'm looking at this literature, the very few articles coming out, and I'm working with a plant that was bringing all kinds of benefits in people, what I started to think, so I'm the first one in the literature that suggested stem cells are really the repair system of the body. But I took that out of bits and pieces in the literature. When I put all of that together, it looked like there was no other way to interpret all this information. Stem cells had to be the repair system of the body.
You were getting special plants from very special areas, looking for let me just back up a little bit. What was your main motivation initially of going to get all of these plants and do these things? What were you looking for? Were you trying to see how they were impacting our health, or what was the original?
This came later. So at first, I'm as a neuroscientist, I always liked plant. And then there's this blue green algae in Oregon that is sold in the marketplace. And the Dietary Supplement Health and Education Act had just been passed in 1994. So I wanted to segue out of what I was doing. And so I was hired by this company selling this blue green algae. And my task was to document how it was working. So I very quickly identified the anti-inflammatory mechanism or active compound, the mechanism on the immune boosting effect, and the effect that it has on the mind. So people consuming this plant would feel like mental clarity, mental energy, like feel good. And we discovered it's one of the best natural source of phenylethylamine, known in biochemistry as the molecule of love. You have it in chocolate as well. So we did that very quickly. But as I'm doing this, I come across people who reversed multiple sclerosis, kidney failure, liver failure, heart disease, diabetes, emphysema, Parkinson, Alzheimer's. So the point is like, wait a minute, either this is untrue, but over time it became really compelling, like 50, 100 cases.
This episode is brought to you by Maui Nui Venison. I personally am always looking for the highest quality protein I can feed my family. And that's how I got involved with Maui Nui Venison years ago. First got it as a present. Well, Maui Nui Venison is the only stress-free, 100% wild harvested meat that's on the market. They are reclaiming food systems and preserving native ecology on Maui. And it's incredibly nutrient dense. It was even researchers at Utah State, and they showed that this meat is some of the most nutrient dense red meat that's available. It's like one of a kind nutrition of place. You've got that volcanic, soil, they're running free. It's really incredible. Venison really has some of the highest protein per calorie ratio, up to 53% more than grass-fed beef. I find that I actually eat a lot less of it, really small amounts, because it is so nutrient dense. And a 1 ounce venison stick, so good, contains up to 10 grams of protein, and that's only in 55 calories, and it tastes unbelievable. A lot of times you'll get this natural meat and it's maybe all gamey. Well, not at all. Maui Nui venison is not gamey. It's really clean, and it's so easy to cook, just a variety of different things. So no one's going to say, hey, it's too chewy or it's too gamey. It's so easy to use. And if you would like to secure your access to the best meat, literally, on the planet to help build a resilient ecosystem on Maui, you can go over to mauinuivenison.com/Gabby and go ahead and get a membership right now. So all you have to do is use the code Gabby, Gabby, and that will get you 15% off your first purchase. That's mauinuivenison.com/Gabby, mauinuivenison.com/Gabby. And don't forget to use the code Gabby at checkout. Enjoy. So if someone's taking it, let's say you can see mood elevation and other things in a week or two. If somebody had something a little more intense, how long and how much of this were they taking before it was like, wait a second, this is really impacting them in a positive way?
What we discovered is that this blue-green algae was putting more stem cells in circulation. What we have today is much more potent, and it works on more people faster. But in the early days, it was out of, 100,000 consumer. I heard maybe like 100, 150 of those cases. So it was like the exception, but exception that was nonetheless real. Yeah. Like, what is it that this plant is doing? Here's a case. To me, it was the turning point case, because until then it was like, is it true? Is it not? What do I do with this? So I received a box, and there's a photo album and a letter. And the woman is describing how when she was 12, she was walking with a kerosene lamp, and she tripped and burned herself on the face, chest, and arm, 3rd degrees. She was scarred all of her life, like heavily scarred. And at 60, so 50 years later, she started to take this blue-green algae, and she said, my scars started to get inflamed, red, and itchy. But she felt it was healing itchiness. So she kept taking the product. She took a picture of herself in the mirror every week, and she says, go see the photo album. And as you flip through the album over 1 year's time, the last pictures, there's no scars left. I can't deny that case. Yeah. I don't have the medical records, but I don't need it. It's like, what else do you know in this world that reverses 3rd degree burn scar 50 years after? Nothing. Yeah. So that one was just like, I need to figure out what is behind this. So that really was what was gnawing at me, to try to find what that plant was doing, until we started to uncover this, everything about stem cells. That was really the push.
I always feel like when you have people like yourself who are in these, everybody wants they need studies, they want to see, you clinical trials, all these things. But to poke your head out and to be willing to take a risk and try something, to be curious, even though we say that this is what we want people to do, I think it's a really hard thing to do. There is a form of academics to this, right? So where do you, Is it those stories like that from that woman, and it's the things you're hearing that motivate you? Like, where do you get the wherewithal to say, I'm not really going to be concerned with what people think. I'm going to go on a limb and see what I find.
I don't think it was ever like a conscious thing. It's just like how I do things. Like I observe reality and I try to explain it. And if the explanation is out of the box, it's just out of the box. And quite frankly, I also don't, how could I express this properly? Like I'm not attached either to what my conclusions are. I'm totally ready tomorrow to say, oh, I screwed up. It was not what it was. So it's really like I'm not attached to whatever we find, but I'm just following the direction where it's going. And that's what really uncovered. And honestly, I think that it is this sort of I think it's my superpower. Like not being affected by what others think, not affected by what academically is the accepted theory. I observe something, and if it makes sense to go in another direction, I just go there. But I don't have an academic career to risk. I don't have a reputation to risk. So it was easy for me to go in that direction. And quite frankly, this theory that stem cells are the repair system, it was already in the literature. Mm-hmm. Like the articles were right there. Right. The first time that we wrote this article, I probably have 30 papers in reference. It was already out there. Even some of the people who wrote these articles, when people went to them and just say, is it true what Christian Drapeau is saying on that stem cells are the repair system? They would say, this is nuts. This is not my research is showing. And honestly, this is what their research was showing. But for them, it was too far to go into something that was like unproven at the time. And yet it became so clear rapidly.
I always find it interesting when you hear about things that your body produces a lot of, like until you're 30, let's say bone marrow, for example, like it's red, it's healthy. And then all of a sudden, you like, then they tell you stories about like, and then at this age, you drop off this cliff. And they talk about it in all, your hormones, bone marrow, all these things. So, just for people to get a real understanding, why do you think there is this drop off at 30? Do we, even have a sense of it? And, because I see that and you always go, well, that was a long time ago for me.
It's not a drop off at 30. What it is that it starts at 2 years old. So your red marrow starts to shrink. But it's almost like if I give you $10 million and I say it starts to drop very quickly, but you still have $1 million when you're 15. It's fine. Right. It's when it keeps going down and at 30 you're left with $20 in your pocket. Now you start to worry about it. Yeah. But the decline between 20 and 30 is small compared to the decline between 10 and 20. So it starts very early. It's asymptotic. So it kind of drops quickly. But the way to kind of shock the mind is to say by age 30, you have lost 90% of it. But it's been a gradual decrease. You had 50% loss at 15. And it keeps going down. Of course, the decline is slower as you age, but you're already left with so little.
Is it used like, let's say during puberty or is there more, do we know if it's used sort of more for certain parts of our development as people or things like that? Or is it just kind of part of being a human and repairing as we go and it does what it needs?
I think, and I'll go on a tangent here because there's no answer to the question.
Yeah, but you have, I think you must have instincts
of course.
About it.
Here's the two things that I can say. Number one, we have evolved over tens of thousands of years with a life expectancy of 30 years of age. Repairing beyond 30 years has never been selected in our evolution. Longevity has not been selected. People mate within, let's say, their first 20, 25 years at most, historically, I mean. Right. So that's when selection is taking place. If you happen to have longevity, it has no impact on what happens in your first few years. So it's not selected. And we, over the past 150 years, we've gained an extra 50 years of lifespan. I don't think we have the biology to have this extra 50 years with full blossoming health. We need to kind of hack all of this. We need to tap and leverage things in our body to get it. So I think the first answer is that. And the other one, your question was?
No, just saying if like it was used as extra kind of superpowers during certain parts of our development.
And I think it's just that when you get that decline, it's not that you use them. I think as they disappear from your body, the loss that is taking place every day becomes more apparent. So because that's one thing that came out from stem cell research. The one is that we experience aging like an old fence in your backyard. Every year it's a little bit more decrepit and it keeps declining. But our health is really a balance between losing cells and replacing them. As long as you have enough stem cells to replace it, you would live forever. But you don't have always the stem cells you need to offset cellular loss because they decline. So there's a point you lose that balance, and that's when we start to experience aging. So when you look at it that way, when you come to your 30s and you've lost 90% of your stem cells, that cellular loss now starts to be much more obvious.
Right.
So it's really that process is evolving over time. And I think, a tangent here. I'm just saying maybe it is for a purpose. Because if we were, as stem cells duplicate, they are immortal in your bone marrow. So they multiply endlessly. Multiplying endlessly and being immortal doesn't mean that duplication is perfect. Right. So you've got DNA damage, you've got mistakes being done in that DNA duplication. So there's a time when you accumulate more and more mistakes.
Yeah, bad copies.
So exactly. So there's a point, if we did not have this decline, maybe it would be at the cost of developing a lot more cancers and stuff of that nature as we age. So I think somewhere it's also a protective mechanism.
Yeah, that makes a lot of sense. So just for people listening, so we know it's created out of bone marrow, but then, you hear umbilical, I got it from umbilical cord. Mm-hmm. And then, there's always the conversation about bone marrow versus blood. Mm-hmm. Blood, it's really, and please correct me every time I'm wrong. It's sort of not really, it's not very good, right? Like you can't really get good stem cells, can you?
Yes.
You can.
You can.
Okay. So we were talking about like the Yamanaka factor. Like maybe we could just get into the differentiating your points of view on this, because I think for a lot of us, it's confusing.
I'm sure. It's confusing for me sometimes.
That's nice to hear.
Okay. Yamanaka factors. It's interesting, Yamanaka factors. It's interesting because he did not discover those things. It's just an application of those things that were really made something new. We've known for a long time that in a cancer cell, so a cell that normally is a normal cell that suddenly starts to behave like a stem cell, which are two main things: self-replication, so they multiply endlessly, and if they metastasize, they become cells of various tissues. That's what a tumor cell is. Mm-hmm. And that's what a stem cell is. The difference is that stem cell, it's controlled, it's organized. It's going to multiply to an extent, and it can become different tissues. But there are 4 genes that are present in an embryonic stem cells that are also present in many types of tumors. So the idea is, let's go back and take a cell of your skin. Let's find a way to reactivate these 4 genes. That was the contribution of Yamanaka. So you reactivate these 4 genes, and now that skin cell behaves like a stem cell. It also behaves like a tumor cell, because they're the same thing. So now that stem cell that cannot really be used today as a treatment, because unless you now muzzle, if you want, its capacity to create tumor formation, then it cannot be used in therapy. And that's why to this day, iPSPs, those induced pluripotent stem cells, are everywhere in research, but they're still not really used in treatments. You need to activate them, and then you need to tame them and restrict them and try to really keep them under control. And while you do all of this, your body has a lot of stem cells that can do the job very fine. Somewhere in the background, it's also because that development is controlled by pharmaceutical. Whereas using your own, anybody can do it. And there's a play power in there, a power play in there.
Yeah.
But
yeah, we won't get into politics, right?
What?
We've had enough of that for like a couple weeks. It's great. This episode is brought to you by Bond Charge. I don't know how fast your year is going, but I can't believe we're sitting here talking about Christmas presents. Well, I've got your back. The holidays are here, and I'm here to save you if you're in need. If you really need a great gift for someone who's just special in your life, or they're hard to buy something, you want something unique or impressive, maybe you want to impress somebody, this will be something that has benefits that will last for years to come, and something that I've been using myself for about 5 or 6 months, and my family. I think it's great, and I've got just the thing for you. It's the Bond Charge Red Light Face Mask, and it really has amazing benefits. The red light will boost collagen production, so the skin will look younger, firmer, and radiant. I want you to do all the things, get to bed, be hydrated, but the red light has been known to reduce the appearance of fine lines, wrinkles, scars, and even blemishes. So if you've been curious, you can order the Bond Charge red light face mask today for the holidays for yourself or for a gift. Yeah, a gift. And my listeners will get 25% off plus free shipping on the red light face mask if you order right now. It's so easy. It's cordless, 10 to 20 minutes a day. All you have to do is go to bondcharge.com and use my exclusive promo code Gabby, Gabby 25. So that's bondcharge.com, BONCHARGE.com. And don't forget to use the promo code Gabby, Gabby 25 for 25% off your order. Happy holidays. I mean, money and health have nothing. They're not together. They're not coupled up together.
Absolutely not.
So you hear people going, like I said, to Mexico. And so in an ideal world, you've created a product that I've actually been taking for about 5 weeks, Stem Regen. I've been taking the athlete formula. I take it right after I work out and right before I go to bed.
What difference have you seen?
For me, it's very easy because, I'm pretty in touch with how I feel. And honestly, it's the inflammation part.
Okay.
And that's everything for me. It's that stiffness and that soreness, because then I always feel like I can get in front of it.
Yeah.
There are times where I don't. And I notice it after about 3 or 4 days for me personally. And I'm pretty hard on my body. And so I had access to your product, and other people do too, but I learned about it. I took it. But let's say someone goes, well, I was going to, for the sake of stem cell education, there's places in the Dominican Republic, Costa Rica, Panama, all these places. In an ideal world, if someone was going to approach, because I know there's a lot of shady stuff going on, what would be the top tier of getting stem cell therapy? What would that look like? And what would the usage be? Is it only for injury? If somebody was unwell in other ways, what are some of the things that, if like your sister came to you and said, hey, I want to check this out. I think people get confused and they are curious about it. Okay.
There's a lot of layers in the question. I'll try to kind of separate them and make it as clear and simple as possible.
And you're not giving people, listen, I always say this is, you're not diagnosing and you're not prescribing. We're just sort of having a 30,000 foot conversation about stem cells.
Correct. From the bone marrow, from your blood, from your fat tissue. These are like the main sources.
Oh yeah, fat tissue.
Your bone marrow, they're great. The only little hiccup is that they're painful to go and get, and they age faster than other type of stem cells. So when you're older, these stem cells are not as potent as when you were young, which has led a lot of times clinics in using umbilical cord stem cells, or even Tony Robbins in his book claiming things that past 40 your stem cells are falling down the cliff and they're worthless. Absolutely not.
As in the quality of the stem cells you make, no matter what, it's just they're a no-go.
They are less effective than when you were young.
Right.
But oftentimes I'm asking people, well, are you running as fast as when you were 15? Are you worthless? They're not as good as when you were 15, but they're not worthless. Like a study, for example, that we're doing on congestive heart failure with Stem Regen. So far, 10 out of 10 patients with chronic stable congestive heart failure have regained normal heart condition after 6 months, and they're all between 65 and 76. All we've done is release their own stem cells.
That's amazing. So did anything else change?
Nothing else.
So everything else stayed the same?
2 to 3 years of being treated for their heart condition, and they've been for that amount. So the condition is longer than that, but for 2-3 years, it's stable, and that's the best that medicine could do. We make them release their own stem cells as a 7-year-old, and 6 months later, they have normal heart function. Just to show, it's not true that after 40 years, stem cells are not good. Are they as good as when you were 15? No, they're not. But they can do the job.
Yeah.
So these are stem cells from the bone marrow. Your fat stem cells are dormant. So they are technically younger. They don't age as fast as you age. So they're a good source of sort of younger stem cells. Not as pluripotent as bone marrow, so they won't become as many types of cells, but it's still really good.
So when the ones from fat, they're not as diverse to be
Correct.
as many different things?
Correct.
Okay.
As stem cells from the bone marrow. But they're good source of stem cells. Your blood has one type of stem cells that is very interesting. They're called V cells. Very small embryonic-like stem cells. You've heard of PRP. So in PRP, they will tell you, no, this is not stem cells. This is PRP, growth factor. It is stem cells. They just don't know. By don't know, I mean, if you're more in the traditional knowledge of it and not following sort of the cutting edge of it, the message is that it's not stem cells. But what we know today is that in these platelets, there's a number of those cells that if you dye them for DNA, they have DNA. Platelets don't have DNA. And if you use marker for stem cells, you see that they are stem cells. So they're very small, the size of a platelet or around the size of a platelet, and they are very potent. They can even become oocytes, eggs, and spermatozoa. So they can do everything in the body. They're extremely potent. They are oftentimes dormant, so you need to sort of awaken them, but there are techniques now to awaken them.
Wait, what does that mean? That's interesting.
Well, like one of the technique right now that is growing out there on the marketplace, that you take them from your blood and you expose that blood sample to specific laser wavelength, and it kind of wakes them up. So, and then they become active. But plants that we have in Stem Regen, we have shown that they do that as well. So they are a very potent form of stem cells. There are a new type of stem cells that are more emerging. Let's say 5 to 10 years in the scientific literature. They're called Muse cells, multi-lineage stress enduring cells. They are, I think, the future of stem cells. When you look at V cells, umbilical cord stem cells, all of these will be the place to go because they're tough. They survive even in stressful conditions, and they can become everything in the body, including eggs and spermatozoa. So they're extremely regenerative.
Where are they coming?
They're coming in right now. You can find them into like connective tissue. They're almost like in every organ, but they're a very small population. So the task right now is to be able to go and isolate them and grow them to turn them into a treatments. And there are a few places in the world where they've started to use with these stem cells, but it's not out there yet. And the other, so umbilical cord, fat tissue, those in your blood, dental pulp, hair follicle stem cells, these can be used too, but nobody is really using them a lot in the current marketplace. In Thailand, there's a place where your child loses a tooth, you put it into a little tube, you send it to the lab, they extract the stem cells, they cryoprotect them, and then you can go there and get an injection of teeth stem cells, essentially, dental pulp stem cells. So these are the different sources that you can have. And then you've got umbilical cord. So these are also adult stem cells, but they come from somebody else. So those who sell you umbilical cord stem cells will tell you that they're most potent, they're young, which is true. All these arguments are true. I'm just going to repeat the arguments that the friends of mine who don't want to use umbilical cord stem cells is essentially for 3 reasons. Number one, it is right now with the FDA, the most commonly reported side effect is an injection of umbilical cord stem cells that was contaminated. So you get sepsis. So you need to make sure you go to a place where they have a really good GMP in place to make sure that these samples are well taken, well preserved, well taken care of. But this is bad practice. So what I mean is that if everything is done well, that should not be an issue. So you go to a good place, it should not be an issue. The other two that are really, I cannot say problematic because it has not showed up yet in the world of stem cell treatment. It's not out there in the literature, but technically is the presence of other component. Like you take an umbilical cord, you want to isolate the stem cells, but in real life, you rarely do like 100% purity. So if you have any other small tissue, stem cells are not immunogenic, but the other tissues are. And so the risk is 2, 3, 4, 5 years down the road, you develop some sort of low-grade autoimmune condition, and you cannot really connect it to that injection that you got. So it's invisible, but you can develop that. The third one, which to me was probably the most relevant, which until recently was just a potential risk, was you can obtain genetic material from a donor that maybe does not work with you or carries a disease, and then you develop that disease. And so that was just an idea until about like 4, 5, 6 months ago, where a study was published, I think in April. So a group of scientists took a human gene that codes for Alzheimer's, inserted that into a mouse, developed the whole mouse, then took stem cells from that mouse, transferred them into a recipient mouse, and the mouse developed Alzheimer's. So that's the first documented evidence that you can take a disease trait genetically and pass it on to another being.
Yeah.
And
I find that so, sorry to cut you off. I find that so fascinating because, so much of disease is lifestyle. It's within your epigenetics. And so I find that so interesting that here in this case, you could actually transfer it.
I mean, there are genes that can be transferred and will create one problem. But oftentimes the epigenetics of this will require some lifestyle to make them express more or less.
Right.
Yeah, it's a combination of both.
That's interesting.
Yeah. And so the animal developed it, but the lab will tell you, but we screen for all the disease. And I'm okay with this argument. But in reality, if you really want to be scientifically objective, you can only test for what you know what to test for. So at the end, the door is open for some risk. I'm not going to say today is a big risk. I mean, honestly, probably not more than any other drugs that exist in the marketplace. So I'm not saying it's a big deal, but these are the reasons why most of my colleagues with whom I work and do the research that we're doing prefer to use fat-derived stem cells and V cells.
Yeah. So let's talk about these plants. First of all, you were interested in plants as a teenager. That's not that usual. Why were you interested? What was your love affair? Why so early?
My only answer is past life. I think.
What about your folks? Like who was anyone interested? Just even someone who was really into nature?
I don't think I had anybody in my life. I really just started to be interested into read. I was a nerd. Like I probably below, like under 20. I don't know. Maybe I went like 5 times into a bar.
It's so funny when we're interested in something different than like societal norms. We think that we're nerds. Maybe we're just ahead. Maybe you just avoided a lot of.
Maybe.
But what does that show up like as a 15 or 16-year-old boy? What is liking plants? What does that look like?
I'm trying to remember. I mean, it's not a direct answer, but here's a story so a few years ago, I went back to Montreal, and where I'm from. And then I called an old teacher, my 6th grade teacher. He was my favorite teacher. So I called him just to meet him. He was in his 70s. And then, so as we're having lunch, he says, I was telling him what I was doing. He says, well, I remember the first day of school. So I'm 13. And I asked him, I said, Michel, how does the brain work? So his answer was, let me check and I'll come back to you. And hoping that I would never ask the question again. And I did not. But it's interesting because after that, maybe when I was like 13, 14, I started to really dive into like self-hypnosis, things about the brain, then neuropsychoimmunology, like the relationship between stress and diseases. And then I looked, the only place where I could study neurophysiology was McGill. So I put my eye on McGill, and that's the course that I went to do. So it started at an age that totally today I could not tell you why this 13-year-old was interested in the brain. Honestly, I really don't know.
It's great though. I mean,
so it started around that time.
It's funny. I think a lot of us are looking for something to be passionate about. I think if it falls on us or it's given to us, it's really a unique gift.
Yeah. I mean, you might like the story because it's part of your life in a way with sports I was doing martial arts, and I think I had my black belt around 14. And then that's when I come across all this information. The book is called Super Learning in English. And I got a translation of it in French. It was called The Fantastic Faculties of the Brain. So I started to really read this. And it's totally stupid. I thought that in my family, nobody has really studied, my mother, my father. So I thought that me at 13 buying with my money a book, that my dad would punish me. So I was hiding the book. And I'm sure it would have been fine. I am sure. Universe. I'm sure it would have been fine. It's a story in my head. But anyway, so I'm reading like avidly this book and all these techniques used to learn fast. And one of their application was in Bulgaria, in Hungary, in Russia. The athletes were like Olympic athletes, were very performant. And one of the things they were doing is that they were doing all this work with their mind. And at one point, Taekwondo is supposed to go in demonstration in LA, I think, and after that to be in Seoul in 88, I believe. So we're in 1980, and they're starting to think about forming Team Canada. So I took advantage of this and I said, I'm going to train in my bed. So every night I would lay down 2-3 hours, self-hypnosis, and I would do everything to fight in my mind. And when we went to the first selection for these games, and I won. I was not like in the top shape because I barely trained physically. But that's the first application of those techniques, which then I turn into learning, like how can you learn a language in a week, for example, that kind of stuff. I wrote a book about this. So plants were like in all of that, like what plants I can use to concentrate longer, that kind of stuff.
Yeah.
That's how it all started.
Yeah. So let's fast forward to STEM Regen and you taking on, this is, it's a it's one thing to be passionate about the sciences and performance and helping people and health. And it's another thing to then try to make a business. It's a whole other dance, because sometimes they're almost in contrast. Like the things you want to be spending your time on, you're sitting here talking to me about this stuff.
I greatly enjoy it.
But you know what I mean? Or like our packaging or, sourcing or things like that. So what does that leap look like?
I mean, unfortunately, I think the moment you get into a direction, you may do this for a reason, and then you end up with things that had you known before, maybe you would not have gone in that direction. So for me, what it was, honestly, so we're in 2001. I have this idea that this plant may work by putting more stem cells in circulation. I have this conviction that stem cells are the repair system of the body. So I'm thinking, man, this looks like a great idea, but I don't know really what is going to come out of this if it's true. So I made maybe like 200 bottles that I shipped to a friend of mine in France. He was a naturopathic doctor, and all of his cases, or many of his cases, were people that the doctors told them, "There's nothing more I can do for you." So these were his people. So I shipped them bottles. I said, "Just give it to them."
Just the pills.
Just the pills of the first product that we had, which is an extract from blue-green algae, this initial blue-green algae. That's all it was. So I said, give it to them and just tell me what you see. And within a matter of maybe 2-3 months, I mean, like one lady, 18 hours a day on oxygen tank with severe emphysema. And then the daughter said, "Oh, my mom says thank you. It's the first time in 10 years that she could climb the stairs at the cathedral to go back and visit that cathedral." She climbed the whole thing and she was not out of breath. Then we have, heart, diabetes. We have the story of that young girl, 4 years old, spinal myopathy. She has never walked. She had never stood up. So the mother asked, would this product help? And I tell her, you'll release stem cells that have the same genetic problem, so it's not going to help. She says, can I still give it to my daughter? As far as I know, France is a free country. So she gave it to her daughter. 3 weeks later, her daughter stood up. 3 weeks later, she's starting to walk. So it's that case that brought this whole understanding. Everything is a balance. So her neurons will degenerate much faster. She has a genetic disease, but if you can replace them fast enough, you maintain functionality. It's that case that led this whole understanding of aging and disease formation that I proposed about 10 years ago in the literature. But my point with all of this is that as I'm seeing all of these things coming, the thought that came to me was like, oh my God, we're putting an end to disease. I did not have any desire or, how could I say, ambition of saying like, I am putting an end to disease. I really thought, man, this whole thing is like, honestly, very naively thinking it's going to change everything. So if somebody else was with me believing in what I was doing, I probably would not have been the front person doing it. Right. Nobody believed it. And I was so convinced that it was true that somewhere unconsciously, but the decision was, then nobody else is there to do it, so it's mine to do. And really, it's like, I kept just moving forward with it. And the first product that we launched in 2005, over 10 years, we sold about 400 million of that product. So it was working. It was successful in the marketplace, but it could not penetrate the medical profession. So I wanted something that was stronger that could really have enough information, enough science around it to really appeal to the medical profession. That's really, for me, was the purpose for stem regen. Something that could, once it's really established, documented, could be seen on par with other types of stem cell modalities.
How do you go about the process of dosage and when to take it, and did you add things? Like what was that process like? And how, and over the when you're sort of saying, hey, we want to kind of kick it up a notch, so that we can get it into more places. Where do you go to experiment? What does that look like?
Well, the evolution of these formulations was, so we have this blue-green algae. Then I'm intrigued, like it cannot be the only plant having an effect on stem cells. So what else? What else has been associated historically to a broad variety of health benefits? Immediately you'll say like goji berries, medicinal mushroom, adaptogens. So we tested all of these. And when we started to test polysaccharide-based compounds like mushrooms, goji berry, we saw the reversed response to what we had seen before, which is instead of an increase of stem cells, a very quick drop in the number of stem cells. So the first reaction was like, okay, there's a problem with the machine. So you clean the machine. Well, it's still happening. So maybe there's a problem with the reagents. So clean the reagents. Maybe it's the antibodies. So trash the antibodies. And after 3-4 months of doing this, no, this is a real response. And as we dug more and more into it, we discovered that some of these polysaccharide increase the density of the receptor that stem cell use to listen to injured tissue, to migrate in those tissues. Mm-hmm. So they disappear from the blood more effectively, so it's a drop. Mm-hmm. So when we start to see this, I'm thinking, although migration of stem cells in a tissue is not a thing in science right now, science has never studied that because you don't have drugs to do that. So there's no documentation, but it's pretty clear. If I want a cell to go in the heart and heal the heart, it has to migrate in the heart. Mm-hmm. So if I have a product that supports migration, I'm thinking, let's combine them. So that's how these formulas have evolved. The moment we find other products that do a work that supports the initial work of putting more stem cells, and we made the formula more and more complex. So now we have 5 of the top plants that stimulate stem cell release by different mechanisms of action. So you get like a synergistic effect. And we have one ingredient that basically trigger their migration into the tissue. And in the sport formula, one ingredient that supports the multiplication and push stem cells to become ligament, tendons, muscles, like to help recovery. So that's how the formula kind of evolved to where it is today.
There's so much to say, really. I think it's interesting because we're sort of, it's really easy for us to accept like, a pill. Mm-hmm. I think it's so hard for us to accept what nature is able to provide us. Mm-hmm. I don't know. I'm not sure what happened to us, where we got disconnected from that. But I always find it fascinating where if I said, hey, if I give you this pill, there's a million maybe side effects, but we accept that. But this idea of something that's in nature in just a specific combination.
I think it's a whole programming from pharma, because in reality, 60%, if not more, of these drugs were first isolated in plants. Yeah. And then you concentrate them, they have way more side effects, sometimes toxicity, but we're trained to think that they're much better than the plants. Yeah. I mean, there's a lot. I'm not saying there's no place for it.
Of course.
But you can do so much with plants, so much.
So if someone's listening to this, obviously, there's so many things that it can help as far as where it migrates to and help with creating more stem cells and healing. Just maybe we could just sort of talk about some of the places long term. You said ligaments and joints, things like that, but maybe we could just kind of travel through the body a little bit. Is there the cognitive impact, mm-hmm. Your eyesight? Is it sort of showing up in all these places?
Yes and no.
I know you have to be careful, so I am saying we'll be careful, but just so people get a sense of.
Let me put it this way. If you take a stem cell from your bone marrow and you put it in the liver, it becomes a liver cell.
Right.
In your heart, it becomes a heart cell. In the brain, it becomes a brain cell. Anywhere in the body, it will become cells of that tissue. So the question now is, as you release your own stem cells, their ability to get to that tissue and reach that tissue is a big part of the equation. Your retina is not easy access in terms of cells. So when you're talking about eyes it's an area where we have seen benefits, but not a whole lot. Because for me, until we do prospective study, like we go into a clinic and we say, okay, we recruit 50 people and let's see, is it 10, 15, 20, is it 50 out of 50 that get the benefits? Until we do a study, we don't know. Because all I hear is people coming and telling me their story, but it's one out of how many, I don't know. So over time, now it's 20 some years that I'm doing this, I can tell you the conditions for which we do see a lot of benefits with people just releasing their own stem cells, and they're not the one that I would have expected when I started. We know that the heart is not really repairing very well. This is what we know.
Why do you think that is? Because
well, it's a post-mitotic organ, meaning after age 8 to 10, your heart cells, you don't make new heart cells, so you've got what you have. So if you lose them, you cannot really make new ones. Traditionally, that's what we thought. And I would realize that it's not completely true. Today, we know that your heart is in the same process of tissue renewal. You replace about 1% of your heart per year until age 50. It's pretty significant.
Yeah. If you go to a cardiologist, they'll say, you only have so many beats.
It's not true.
Have you ever, because I had AFib for a while. I caught COVID in January of 20, and also it was simultaneously to being 50. So I think it was between hormones and kind of getting COVID that I had AFib I didn't say anything for a really long time. And one day I was sitting on the couch and my husband looked at me and he was like, "What's up with you?" And literally my heart rate was like 120, 130, wow. And so I just went to get things checked. But, they'll tell you, oh, you only have so many beats, heartbeats in your lifetime. Did you know that? If you go to cardiologist?
I've heard it, but I don't. They really say that?
They say it. And my heart was in great shape. Like if you look at my heart, a picture of my heart, it was fine. It didn't have anything to do with that. So this is the kind of stuff that we hear. Yeah.
It's back to normal?
It's for the most part.
Okay.
I have something downstairs called that Pure Flow machine.
Okay.
That, I just think I don't want to say it's not uncommon, but it didn't feel like it was really that uncommon. Just seemed a little bit like a perfect
We've
storm.
Never studied it, but I have heard people coming and saying that it took care of their AFib, that it took care of valve, like valve prolapse and things like this. Honestly, there are many things that I cannot explain. I thought when I started stem cells will build new tissue. That's what they do. They multiply, they build new tissue. So how can you explain that people suddenly see their cysts disappearing? We've had people with like really deformed hands and feet with rheumatoid arthritis, like bone growth, and it reversed the moment we start to release stem cells. I have no explanation for it.
What happens? Like if someone, if I'm hearing that, my brain doesn't, it's sort of, there's a lot of things I understand. What goes in? Is it goes in as a soldier and gets the system to work more, function at a more natural level and get things back to, let's say, quote, normal? Like what happens that it can turn some of this stuff around?
Normally, the way that they work, they're the building blocks of your body. So they're the blank cells. They go anywhere and they can repair the tissue. What will make stem cells lead to removing a cyst or bone growth? My only explanation, which is not an explanation, it's close to what you just said. It's a fruitcake explanation. It's just like it makes that tissue start to function more optimally, and it kind of resume its own blueprint. That's the best way that I can explain it until we have a better explanation. But we've seen it many times.
What I hear in a lot of conversations, it's like adaptogens. Adaptogens don't really, quote, do anything. They just put you in a situation for your body to take care of itself, to do it. And in a way, for me, what I really appreciate and I accept fully is that we can heal ourselves. We just have to get put in the right situation to do it. And so this feels like getting ourselves in that situation to be able to heal and function the way we're meant to.
Yeah, we have seen a number of these adaptogens working by triggering the migration of stem cells, which by itself is powerful, meaning you don't put more stem cells in circulation. Those that you have, you make them go where they need to go. So just in itself, is great. So what we did with Stem Regen is blending those two together, essentially.
What about lifestyle components? So obviously plants, I would put that as part of a nutrition. So clearly there's things in lifestyle. So from your own point of view, as somebody who's been pretty focused on this aspect, Are there other parts? So for a younger person, if they're exercising and maybe they have better nutrition, does this impact? It probably doesn't impact the amount of stem cells. Does it impact the activation? Does it impact how they work, how they function?
There's not a lot of work done there. All I can say is that the reason why a young person doesn't care about this, like you want them to care and they don't, it's because they have so many stem cells, they don't see it. Yeah. Their repair power is strong. So they start to think about it when you cross 30 something, you realize you don't repair as well. So, but at any age, what will reduce the ability of your stem cells to do their job are things like cigarette smoking. So you actually take a stem cell from your blood, test it with its ability to migrate, proliferate, differentiate, and then you smoke, and then you take stem cells again out of the blood a few minutes later. And then you test those stem cells, you've shut down their ability to do their regenerative work. And it's not just the smoker. If you filter the air and then dissolve that with stem cells, you create the same thing, the same inhibition of stem cells. And in the study that I saw, it was stronger into the air, the filtration from the air. I'm not going to say it's significant, meaning like the secondary smoke is worse than the primary smoke. But at least for now, let's just say it's you, the smoker, and everybody around you that pay the price.
Yeah.
So smoking. Alcohol will do the same thing. I don't know if it is like long-term alcohol or is it just the day you drink that you suppress your stem cells. But at least for now, let's say the day you drink, you'll suppress the role of your stem cells. To me, the worst and the most meaningful from a society standpoint is stress. If you take a rat and you take its stem cells, then you put it in a pool and he's stressed, and then you take him out, take another sample of stem cells, and you test those two samples, you have shut down stem cells' ability to migrate, proliferate, and do what they do in the body. If you do the same process but remove the adrenals, you don't have this effect. So it's the stress hormones are suppressing stem cells' ability to do their job. I mean, can you find a person in today's world, in our modern society, that is not stressed since the age of 5?
Yeah.
And actually in the world today, probably more so when they are younger. Yeah. But I mean, everybody lives with stress. So I would say it's super important when we pass 30 to really have a good strategy to manage stress and just not sweat the small stuff.
You seem, for me, as somebody who'd be visualizing in their sleep as a teenager and interested in all these bigger concepts, probably a person who, I call it, sort of you fly in the cleaner air. You don't seem like a person who maybe hit some of the regular snags that people hit. But do you have a practice as somebody who is busy dealing with business stress? You guys travel, you're making changes, life changes. Do you have things in place to manage this stress and practice just for you?
Yeah, I mean, it's a simple answer. I mean, when I quit my PhD, I went to live in a monastery. So it was like a little stint before going back to research. And I've continued since that time. So for me, meditation is a part of everything that I do. But the quick answer to your question is really through meditation, observing that everything that the mind does is rarely true. It's just the mind is just spinning around and weaving stuff that is not real. So anytime I'm stressed, honestly, it's like whatever I'm stressing about is not real in the way that I'm stressing about. I'm not saying that I have to pay my tax. Yeah, I have to pay it. It's fine.
Yeah.
But all the stories I make about it and the stress is not part of. There's what I can do, and I do it, and I don't stress about it. So it's really every time there's stress, it's just immediately just say, all of that is just stories that the mind makes.
Yeah.
It makes everything much simpler.
It really does. It takes a really long time to even be able. I float in and out of it, and it's taken me a long time to even have the moments to go, it's not worth it. It's very interesting. What about light, blue light, LED light? Have you tested any of the impacts of the ability for the stem cells either to mobilize? Because I sort of feel, and you hear and do a lot of reading and things, that maybe that is harder on us than we realize.
Probably. Not on stem cells. I've never heard of anything like this with stem cells, like blue lights. Red lights, It helps repair, but I don't know if it's because it has an effect on stem cells or because it will locally pool more of your blood, increase blood circulation, so give better access to the stem cells that you have in your blood to that area, which will then lead to better repair. Pulse electromagnetic frequencies has been well documented to actually boost stem cells. Probably a lot of the benefits of PMF is because of stem cells. So it will make stem cells migrate more easily in that tissue, proliferate, and differentiate into tendon, ligaments, bones, and a lot of those types of tissues. And quite frankly, maybe other types of tissues. It's just that the research so far has focused on those, on anything pertaining to a joint, because that's why the technology has been mostly used for.
Right. I have. We had one of those beds that you lay on. You know, that tick, 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 and it has the pads and. All of that. Have you ever tried that one?
Yeah. Well, I have one of those big machine at home. I love it.
It is. It's great. It's like you never know. And then when people think about walking or some type of cardiovascular exercise, have you ever tested something? I'm just curious because I think people, it's almost like they don't believe the medicine that is either the food, which you're saying over and over with the plants, or movement. And then I'm also curious about sleep. If we know, I mean, I would imagine it's obvious, but just to remind people.
Sleep will support the proliferation of brain stem cells. So that has been, I wouldn't say like vastly documented, but there's a few studies that have been done and showing that good deep sleep will support a proliferation of stem cells in the brain. You mentioned sleep, exercise. Exercise is a big one. The only thing is that now that I'm looking at it more and more, I'm thinking it may be mitigated. And what I mean is that it has been documented that you release a lot of stem cells when you do like intense physical activity, like running a marathon. There's even a study that showed half a marathon was not enough.
So duration, a longer?
I think it's all related to tissue damage. You trigger tissue damage, you trigger a repair response. The repair response will lead to more stem cells in circulation, but as a mean of healing, you now have released more stem cells, but you've released them for a reason. They need to go repair something. If they're used elsewhere, maybe over time you actually accumulate more damage in these areas. Because you look at athletes sometimes that have worked a lot, and they carry some like consequence of having abused their bodies. So
are you kidding? I mean, I'm sitting here. I have an artificial knee sitting here with
you. There you go.
Yeah, of course. That's another conversation for another day. But I always say people have no idea. If you are doing that much repetitive motion, you pay.
Correct.
Yeah. So you're saying those get mobilized because the need is so great, and it better go to those places. Otherwise, you're really going to have a problem.
Yeah, but they don't all go there. Like they go back to the bone marrow. They can go to other places. Yeah. So athletes are healthy, but I think at the end of the day, it's not like your best strategy to put more stem cells in circulation to go and beat up on your body every day.
I'll go run 100 miles.
There you go. You go.
That's so funny.
So that's one way to put stem cells. But I think the way that it also supports healing in the way when we talk about stem cells is just like we talked about walking before. Simple physical activity will open all your microvasculature. And I think that this is one thing. I remember my class I loved that class of blood, like hemodynamics, when we studied blood circulation and how when the blood goes from one vessel to two vessels and it forks, how it creates like turbulence. I love this whole thing. And I came out of all this study just wondering, why don't we talk more in medicine about the fact that the blood that you have in your vein, your arteries, like you go to your doctor, he takes a blood sample, they tell you everything that you have in your blood, but this is completely worthless if it doesn't reach your capillaries. It's worthless. So what you have in your blood is only good and valid if that blood can reach all your fine microvasculature, which is probably the case in any kind of chronic injuries that is not repairing. You probably don't have, because of inflammation, good blood vasculature, microvasculature. So physical activity pushes the blood into all this microvasculature. I think it's one of the great,
that is interesting,
the great benefits of
Do you think
moving.
Things like sauna or things that would sort of create this kind of movement would also be helpful in pushing that blood around?
Yeah. Sauna, cold plunge, doing one and the other, cold shock protein, heat shock protein.
I'd love to see if one day you did something on vibration.
Absolutely.
I don't know. I'm at a place now where I've talked so much about food and movement that now I'm interested in Hertz.
Yeah.
Because it's like, because I think it's more trying to get back to your basics, and then you start peeling it back and you think, oh, there's so many things with vibration and things like that really are helpful. And I would imagine as somebody who has had a different past, I mean, if you were meditating, were you guys ever doing chanting or any of that? So I mean, that's all that is, right?
I mean, it's a
form of.
It's a form of vibration, but like I think this is the work of Doris Taylor. I don't think she published it. She's a great scientist.
Yeah.
I don't think she published it, but somewhere she mentioned it, and I had a conversation with her. She confirmed it, that if you have a good meditator, 20 minutes meditation, and an hour later you increase the number of stem cells.
Yeah.
So there's a healing part to meditation, but vibration, I've heard of it. I've never seen it in the literature, but I would 99.9% sure that just good, like a vibrating plate. Just stand on a vibrating plate. I'm pretty sure it will release stem cells.
Yeah, and if nothing else, you just have a different perspective. I'm curious also for you, if anything new and surprising in kind of these formulations has shown up in the last 5 years. Like, somebody brought you an ingredient that really surprised you that hadn't been on your radar. And it doesn't even have to be something that's in stem regen, just something maybe you've put in practice for you in your own supplementation, or something that you yourself have really seen a benefit from.
I mean, I've used, I don't know if there's an effect on stem cells, but I used a few plants that I think are just amazing for health. There's a few of these plants like that, all the concept of senolytics.
Yeah.
Yeah. So plants that will act as senolytics. I've started to really play with these plants for the past 2-3 years. I have not seen the benefits in me, but I think it's definitely a path that is really good to keep diving into. Shilajit, you've heard of Shilajit?
Yeah, my husband.
That is a foundational product for me.
I'm so glad you said that. Laird's been taking Shilajit for about 20 years.
Okay.
And originally, the one he really had used to be really stinky. He's found a lot of ways to mask it. But you take Shilajit. Do you drink it or take it in a tablet?
No,
How do you
I
like
drink
it? So you make it in hot water?
I take the tar
something?
in hot water. Yeah.
You do it for real. Okay, I have an idea for you. Laird has a chaga pot over here brewing, and so he takes chaga and a little dollop of the Shilajit, and then he takes a little bit of the mocha creamer, and he puts it all together. It's quite good, actually.
I honestly, the taste is bad. There's no question the taste is bad.
It smells worse than it tastes, though, don't you think?
I mean, we take it fairly concentrated, and then so the taste is bad. But my body says yes.
I know.
Anytime I drink it, the body says yes.
Yeah.
And the first time I had it, I there was this dichotomy. It was awful, but my body just liked it. And the first day that I took it, I slept so well on that night that I kept taking it. I wouldn't say like every day, but we always have it at home.
Just get it in.
We take it like regularly. So that's a cool one.
Okay. What other secrets do you have? Because you know a lot of stuff.
Black seed.
Yeah.
Black seed is one of those, like, you cannot take it all the time. It can lead to some sort of liver problems, but periodically it's a powerful plant. Nattokinase. This is something that is not used enough. It has so many benefits.
Have you ever eaten natto itself?
I love natto.
I have a kid that she grew up in Hawaii.
Okay.
So there's a lot of Asian influence. So for people who don't know what natto is, it's a fermented bean. It's stringy. I mean, it has a lot going on. But I think it's to your point about Shilajit. Like once you eat it, you're sort of like, yeah, give that to me.
Do you just eat it just like this?
She puts it on a little rice. I don't mess with it. I take the supplement. I don't mess with natto. Natto kinase. When I heard that there was a supplement, I was like, I'm all for it.
So if you take natto and you put an egg in it, you mix it well, and we put a lot of chive, and then what else do we? I think we put a little bit of tamari sauce, and then you mix it well.
It's okay. It's doable.
I don't think I can leave anything in the bowl. I eat the whole thing.
It's so good.
Yeah, I like it. So natto is one.
Yeah.
What else can I think of? Kava. I'm a big user of kava. Big user of kava.
Where do you get your how do you prepare it? Where do you get your source for it? Because I think a lot of people.
I've looked for many sources, and quite frankly, it's not easy to find a good one. The one that I really, that is by far the best, is no longer available in the marketplace. It was a product from Johnny Sterling, Amazon John. It was a product called Cavazon.
Oh, wow.
And it was a blend of many plants. And this one, honestly, like I would go to conferences, and after I give a lecture, there'll be like a line of 100 people with questions. After a few minutes, like, I'm done with all these questions sometimes.
Yeah.
So I would say, give me a second. I'll take a shot of Cavazon, and I'm so loving all the people, and I can answer a question all day long. And it was totally fine.
Yeah.
So that product just makes me love everything, everybody, all the time.
Yeah.
So I love this product. And since it went off the market, then I tried many sources of kava, and I've not found
a good one?
I found good ones, but nothing. Like, there's one now that I just found, Jaya Herb, as a new one, and I'll try, and I might develop a product with it. I'll see how it goes. But right now, my conclusion as of today, I need to go back to buy the root and do the same good old extraction that John was doing in his product, which was a spargeric extract. You first extract it for a week in water, then a week in alcohol, then you burn the ash and you blend. Like, it's a process.
Yeah.
But it was so good that I might have to go back and see how I can do something like that. But I use a lot of kava. It's really, we talked about stress before.
Yeah.
I'm not easily stressed, but kava is really good at that.
Speaking of kava, if you heard that noise in the background, that's my dog Kava. So he
There
must
you
have really been.
Maybe you heard it.
I really appreciate that, because I haven't incorporated kava at all as a practice. So I'm going to explore that. I really do appreciate that. So kind of wrapping up and focusing back on stem cells and stem regen. So if somebody wanted to explore, we've talked about stem cell therapy, stem regen itself. You have a few different types of products. So if what product is for who, and why are there just a couple different ones?
Okay, so Stem Regen Release today, Stem Regen Sport, is the primary product. And over the years, we see that. So let me just first lay the basic information. Your stem cells are working. If they were not working, you would not be alive today. If you have a new liver every 2-3 years and you're still good today, that means your stem cells are there, they're doing the work. Why is it that when you release them, in some people, they don't see the benefits that we would expect? Why it didn't work for them? So over the years, we've done a number of studies, and a few things that emerged was, one, systemic inflammation. People that have systemic inflammation, we don't see the same result in them. People that have poor microvasculature, we don't see the same result in them. So the other two products that we have developed, so Mobilize and Signal, were made to address those issues. So Signal is a product that is all kind of plant extract that will suppress the enzymatic activity of the activity of specific enzymes involved in inflammation. COX-2, 5-LOX, the production of various cytokines, 2 most necrosis factors, all those inflammatory compounds, we suppress them. We have bromelain to digest those that are already in your bloodstream. And the idea is to suppress the background inflammation. You talked about Stem Regen Sports having an effect on inflammation. When you feel inflammation and it's in your bloodstream, that's because you got many areas of small site of inflammations that don't get repaired. They build the systemic inflammation. The moment you can start to repair them, they stop leaking inflammation. So the point is, when you get stem cell inflammation in your bloodstream, it blinds stem cells in their ability to find where to go. There's just too much noise. So we call this product Signal because it basically increases the signal to noise ratio. We lower the background noise, and we allow stem cells to find where they need to go. But oftentimes in a chronic condition, the microcirculation is not good enough. So Mobilize is a blend of nattokinase to basically increase blood fluidity. Then we have nitric oxide producers to dilate the capillaries. Then we have antioxidant, bioflavonoids, plant extract to help rebuild the environment of the capillaries. And we have the polysaccharides to rebuild the glycocalyx. So stem cells can really flow more easily in those capillaries. So with these two products, we basically eliminate two of the obstacles that really open the path for stem cells to go where they need to go. And if anybody has a general problem with systemic inflammation, well, Signal alone is a good product for them.
Right.
If somebody knows that they don't have good microvasculature, then Mobilize alone can help for that. But they were built as a trio, as a system, a protocol, to basically say when you release stem cells, you give them the best chance to go where they need to go.
Yeah, I really appreciate the brand, and I appreciate your work. And the other thing that I always am so happy about is that when you talk about ingredients that you hear over and over are good for a lot of things. We're talking specifically today about stem cells, but a lot of these ingredients you're talking about it's that reminder about creating that buoyancy for the system and to get away. Inflammation is good, but chronic inflammation isn't. So I really, really appreciate it. So just if you can remind people of all the places they can find you, or if they're interested in Stem Regen and to learn even more about the product.
So the main website is stemregen.co, so stemregen.co, where they can get really all the information that would, like blogs, all the science is there. And then all the answers to questions, I do that at Stem Cell Christian on Instagram.
Yeah. It must be fun. You're like a little bit maybe of an introvert, so this must be really fun for you. All this stuff you have to do, right?
I'm a lot of an introvert. But yeah, social media was, I had to be convinced to do it. But I like it.
You do? Well, you're helping people.
The feedback of it, for me, the fuel, if that response was not there, I don't know if I would do it in the same way. But it's really how it's really helping people. I find it extremely, it's great.
Well, Christian, thank you for your time, and I do appreciate just you not only sort of following your path, but being willing to put together something that is unconventional. I think you're on the beginning of a frontier that in 10 more and 15 more years will be really even more commonplace than it's been. But I really appreciate that. And actually, one last question, because I know a lot of people will wonder this. Do we think that the other types of stem cell therapies are going to become more affordable and sort of kind of less wild west, or is that maybe just the nature of that part of the stem cell quest?
I think it's unavoidable that it's going to be much more available as we move forward, because right now the blockage for it is entirely political. Yeah. So there's a point where all of this will have to give, and then we will have greater access to it. But I think that in the background, had we known in the early 2000s what we know today, which is that your own stem cells can do the work. Have we known that early on, this whole field of collecting stem cells, tweaking, like this whole part would probably not have developed as it has developed. So I think somewhere when what we've been talking about today, like the power of just releasing your own stem cells, when that finally gets well documented, we publish all these studies and we really show what this can do, releasing your own stem cells. For the vast majority of the people, that will be the best thing to do, because an injection, like you cannot go every month to get you cannot go to get a stem cell injection to recover from your workout.
No. It's not possible.
It's not possible. No. But you can release your own stem cells.
Yeah.
So there's a point where the application of it will become like so much more part of your daily life that I think that this is where it's going to be in a number of years down the road. Yeah, and stem cell injection will still be there.
Yeah.
Probably cheaper. Yeah. But at the end of the day, is it going to be really more effective than the cumulative effect of daily releasing your own stem cells daily? I'm not sure.
Let's say somebody overall, like things are pretty good. Like me, I have inflammation, but overall the markers, my lifestyle is pretty good. And let's assume that if I took Stem Regen, that it could get to the site. So I've got good circulation and blood flow, and I'm not chronically inflamed. What would that product do for somebody just in that athletic recovery?
The first thing that will happen, which you may have experienced, but we hear this all the time, is that you go to your workout, what will create the soreness the day after is all the micro traumas that have been created that now make like a million little sites of inflammation, and they create the pain. But if that tissue can repair faster, then you won't have that soreness. So you release stem cells right after your workout, and you will see the day after you have a whole different experience with the soreness. And where that matters for an athlete, and you know this more than I do, although I did it when I was in my teens, but when you go back to train, the day after you train pretty intensely, you cannot train to the fullest. You're training on top of soreness. And you do this every day. As an athlete, it's your life. For years, it's your life.
Yeah.
And any of these micro injuries is where the big injury will come down the road. So if you repair these faster, every day that you go back, you can train more like to the fullest because you have repaired what you created in terms of micro injury the day before. So I think over time, the reason why so many people take stem regen sport and they come back with higher performance is not because the product has any kind of performance enhancement activity or benefits. What it does is that the time that you spend training, you get more out of it because every time you can go more to the fullest.
Yeah.
And you don't experience the same risk of injuries because you don't have all these micro lesions that are opening the terrain for an injury. So I think that this is where, because we've had these stories like forever.
Yeah.
I remember, for example, somebody who became a good friend of ours, Frank Condon. So he was a runner doing the 1500, and I think he missed the Olympics in 72, I believe. And he had an injury. And then in his 50s, he started to compete in the Masters. And at around 54, I think, he had his own record. And we launched our first product when he was 63. And he beat his record at 63. He beat his record at 54, at 54. Then the year after, he beat his record, and he established a record the year after. And the point here is that he could, anytime he trains, and it's just one case, meaning many people establish their own record after taking sport for a while. And I think the only reason is that by repairing these micro injuries every day, you end up with just greater performance over time.
Yeah, and what I hear you saying over and over that I really, it resonates with me is you're not saying, hey, this is a miracle and this is doing it for you. It's saying, hey, this is supporting your body so that it can recover to the best of its ability and setting it up for that success. And that really is the part that I just find very appealing.
If you look at the curve of the decline in the number of stem cells with age, the only thing that we do is that when you're 30 or 40 and you're not repairing as well, or 50, if we just double the number of stem cells in circulation, you will be at the number that you were 10 to 20 years before. So all we do is that we're giving you the repair power that you had, let's say 15, 20 years ago, when you did not have all the suffering and all the soreness and the consequence that you have today. So that's really all we do. We bring back your body, its repairability that it used to have.
Yeah, and it's also that benefit of when you're feeling good, so you're moving more and you're moving more, so you're more tired and you're sleeping, and then you're in this up cycle, then you have more muscle mass and all of these incredible things. So I really agree with that.
Plus you go get an injection. Let's say you go for your diabetes, let's say. But if I were to sit down with you and say, okay, what else besides diabetes? Well, I have my knee, I have this, I have that, or I don't play golf. So it's a lot of things.
Yeah.
So when you do this daily, it starts to take care of a lot more things than when you address one issue. Yeah. So I think it's going to go deeper in people's lives, this daily application of stem cells.
Yeah. You mean like a whole being?
Yeah.
You mean the whole being?
The whole thing.
Hey. All right. Christian, thank you for your time.
Thank you.
Thank you, everyone. So thanks again for joining me and listening to the Gabby Reece Show. Make sure to like and subscribe so you never miss a conversation. And if anything showed up today that you find would be helpful to someone you know, pass it along and make sure to share with us what really resonated and stood out for you in this conversation. Thanks again for joining us. Keep going, and I'll see you next time.